So one thing I thought might be useful is for me to take you through the sort of running example that ends both chapter 4 and then a follow-up example that ends chapter 5. One of the things about my class that I think sets it apart a little bit from, say, the typical principles of micro course that you would see, um, is that I try to add a little bit more quantifying complexity. Not because I want to make economics all about math, but really what I want students to see is that the quantification of economic ideas helps to solidify both the economic ideas as well as giving you some additional insight as to quantitative skills and the ability to use math and apply them to decision making. This is one of the things that I found to be so exciting about economics when I was an undergraduate student, was sort of finally putting the pieces together as to how I could take economic ideas, quantify them into mathematical structures, and then really use them to not only understand the world around me a little bit better, but in many respects to perhaps make better decisions. Now, of course, the example that I'm going to go through here is hypothetical and doesn't really ever I've never made these sorts of decisions as an individual, but it's an encapsulation of what is an extremely common decision that firms have to make, which is what is actually the profit maximizing number of product for me to produce. Now, in the real world, of course, this decision is extremely difficult because you know that, most likely, some portion of what you'll produce will get purchased. If you're lucky and you have a very popular good or a very in-demand good, of course, that's the same thing, you might, of course, sell out. And so maybe you make more in the long run than you did previously. But the decision of how much to produce, as is the decision to hire capital and hire labor, is a profit maximizing. And so we can use optimization principles both to illustrate an economic point, profit maximization, but also show how this would actually be carried out in the real world. And in this example, what I show you is that you can actually arrive at an optimal point without doing any of this math that I'm going to show you in this particular example. You could sort of get to the profit maximizing production level by trial and error. And of course, this is most often what businesses do. It's certainly improving for a business to produce an amount that gets close to their profit maximizing position, and probably this maybe what sets successful business people apart, or at least something that sets successful business people apart from those who don't see as much success, is the ability to calculate what is that profit maximizing, or at least near to that profit maximizing quantity. Of course, in this example, it's set up. We're going to have an explicit answer, but I think you'll see the process, and I think you'll sort of see what I'm saying. So in this particular example, we have Ron Swanson, who is a tomato farmer. And the important stuff is that first, the market price for a tomato is $5. So he can sell his tomato at the farmer's market for $5. And then here's his cost function. And his cost function has two components. It has a variable cost component. This Q here refers to how many tomatoes he produces. And so we can calculate his variable cost for any given level of tomato production. And then he has this fixed cost component, which is his fee that gives him a slot at the farmer's market. So this 500 has to be paid regardless of how many tomatoes he ultimately sells and ultimately how many he produces. And then, of course, this part will change with respect to how much he produces. And we'll come back to marginal cost here in just a moment. I think a lot of students, when they first see this, they see a little bit of math here, they get a little worried. It seems like maybe this is a complicated situation, but here we're just going to plug values in, and plugging a value in, calculating it is very straightforward. So one Saturday, Ron brings 300 tomatoes to the market, sells all of them, and if he does so, what are his profits? So all we do is just plug in, and then we solve. So he takes 300 tomatoes and sells them all. So this is 300. And then, of course, his total revenue. So we see this is the total cost portion right here. So we just plug in, so 300 squared, 10% of 300 squared, um, and plus the fixed cost. And then we have the total revenue portion, which is just the market price times how many he sells. And so his total revenue is $1,500. His total cost is $1,400, and he has profits of $100. So when he takes 300 tomatoes to the market, he goes home with $100 in profits. So the next Saturday, he decides, well, he's going to vary how many tomatoes he brings to the market, and then he's going to see what his profits are. So here he takes 200 tomatoes to the market and sells them all. Now, before I go forward, why don't you go ahead, do the calculation here for profits, get a little practice in with how to calculate profits, pause the video, calculate profits, and then move on, and we'll see if you got it right. Okay, so if we plug in $200, 200 tomatoes rather, into the profit function, his total revenue is $1,000. His total cost is $900. And we see his profits are in fact unchanged at $100. So his profits at taking 200 tomatoes to the market and selling them all is equal to his profits of taking 300 tomatoes to the market at all. You know, this could be a signal that $100 is all that he can make. That certainly could be the case. If you take various amounts of your product and you sell it, and then your profits are the same, it could mean that you're identified something close to the maximum, right? You're sort of on either side of the maximum at that point. So go back to the way that we think about profits, and we think about profits as being about producing that profit maximizing level. And if you produce less, too little, your profits aren't as high as they could be. And if you produce too much, your profits aren't as high as they could be. So if you produce 300 tomatoes and your $100 in profits, and then 200 tomatoes and $100 in profits, that is perhaps a signal that the profit maximizing level is somewhere between them, right? Because you have profits which are equal on either side of a production decision, 300 and 200 in this case. And so maybe the peak is somewhere in between them. So we don't have to necessarily go through and check this by plugging in a bunch of different values for tomatoes and seeing whichever one maximizes profits. We can actually just use math or economic math to make this decision. Just remember, profit maximization occurs where marginal revenue equals marginal cost. Again, this stems from that first equimarginal principle that we've talked about throughout the entire course so far, right? That net benefits, in this case profits, are going to be maximized where the marginal cost of something is equal to the marginal benefit of something, right? Well, we refer to this as marginal cost, and then of course the marginal benefit to the firm is marginal revenue. So we need marginal revenue to be equal to marginal cost. Well, we know what marginal revenue is. It's just the market price of a tomato, right? So the market price of a tomato is $5. This means that that's the marginal revenue. So in other words, all we need to do is produce until our marginal cost equals $5. So if we produce and sell, ultimately, tomatoes, we will maximize profits when our marginal cost is equal to $5. Again, marginal revenue, which is the market price here, which is equal to 5, equal to marginal cost. That's the rule. Marginal revenue equals marginal cost. When we do this calculation, we said here's marginal cost. And again, we got marginal cost from here. So 0.0Q. For those of you who have a calculus background, you'll notice that this is simply the derivative of the cost function. Again, if you don't have a calculus background, it's not important. But if you do, this might make a little bit more sense to you to point out that this is a derivative. So here's marginal cost. So we take 5, we set it equal to that marginal cost, and we solve, and we get 250. And so this says that profit maximizing number of tomatoes to take to the market is 250. And again, we had sort of established that 300 and 200 seem to be on either side of the profit curve. And so somewhere between them was the peak of that curve. And of course, we can run the calculation, and we can see that if Ron instead takes 250 tomatoes to the market, sells them all, that his total revenue is $1,250, and his total cost is 1125, and so this means that he has profits of 125. Noticing that the profits of 125 are higher than the profits of $100 at 200 and 300 units produced. Okay, so now what we're going to do is we're going to jump to the end of chapter 5, and we're going to go through another example featuring our farmer Ron. Again, one that I think might seem like it's complicated at first, and it is. It's got a certain amount of complexity to it, but I think if I walk you through it, I think you'll see that it's pretty straightforward. So the way the setup here is that, again, Ron Swanson is a tomato farmer who brings tomatoes to the farmer's market. Now what we're going to do is we're going to peel back the onion a little bit on Ron's tomato empire. Specifically, what we're now going to do is we're going to consider his capital or labor decisions. And the way that we're going to do this is we're going to sort of first establish that his total cost function looks like this, where his labor cost, which is W times L, that's the wage he pays his employees, and then L is the number of employees he has, plus the rental rate of capital times the cost of capital. The rental rate of capital times the number of units of capital used, and then of course the fixed cost component, which is not a function of employees and is not a function of the amount of capital that he purchases. So the variable cost function is just his labor cost plus his capital cost, and then he still has that fixed cost. Again, this may look a little complicated, but just again, break this up into its various components. Labor cost, the wages times the amount of labor that he employs, capital cost, the rental rate of capital times the number of units of capital purchased, and then the fixed cost component. And we just, just to kind of keep in mind, fixed cost in this example was $500. But, we'll see that factor in just a moment. So this means that his profit function looks like this. Ignore this annoying little artifact of poor editing on my part. So his profit function looks like this, where this is total revenue. Again, this looks like maybe a difficult equation, but it really isn't. So this is just total revenue. This is his labor cost. This is his capital cost. And this is his fixed cost, right? So what we want to do is we want to start to see that we can now answer additional questions about Ron's decision-making with respect to just his capital and labor decisions. Okay, so what we're going to do is we're going to give the cost, the specific cost of capital and labor. We're going to say, the amount of capital and labor that we ultimately employ are going to be simple functions of the amount that we produce. What I mean by this is that how much labor I ultimately employ, the number of employees that I bring onto the farm, is equal to some function of how many tomatoes I grow, which should make a lot of sense. So, I might hire a different number of employees if I was going to grow 200 tomatoes versus say 300 tomatoes, right? So I think that makes a lot of sense. And the same thing with capital here, right? So again, if we have 300 versus 200 tomatoes grown, we will see that would likely lead to a different capital decision. So what we're saying is that the amount of labor that we that we employ, and the amount of capital that we purchase and then use is a function of how many tomatoes we plan to grow. Okay, that's all we're saying here. And so what we can do is we can plug in these values for L and K in our previous function. So you can see all we've done here is we've plugged in L. So this is just L, this is just labor cost, but we're just going to go ahead and plug in this function here. This is capital cost, right? This whole function. And then this is just that K here, right? K equals 0.002Q, 0.002Q times R, okay? Again, this may seem like it's very complicated, and I admit that there is some real complexity going on here, but all this is the same thing that we have up here, which is that this is total revenue, price times quantity. This is how much he's going to pay for his employees, which is how many employees he's going to hire. And so we just stated that the number of employees that he hires is a function of how many tomatoes he plans to grow. And we said that that was 0.02 Q. And so therefore, this is simply his labor cost. The wages he pays the number of employees that he hires times the number of employees that he hires relative to how many tomatoes he wishes to grow. And the same thing for capital, right? This represents the amount of capital he needs to purchase to grow whatever amount of tomatoes he wants to grow, and then times the price of each unit of capital. And then, of course, we still have the fixed cost here in the form of $500. So this is a profit function, okay? So we're going to make some further assumptions here. We're going to assume that the wage rate is $100 per Saturday. So this is what he pays his employees. Each Saturday, he pays them $100. And we're going to assume that the rental rate of capital is $250 per unit of capital. If we recall from chapter 4, the market price was $5. And we also remember that Ron maximizes his profits by bringing 250 tomatoes to the market. And again, that was found in the previous example in chapter 4. The profit maximizing number of tomatoes was defined by the market price, right? So the market price, which was the marginal revenue, we said that equal to marginal cost. That gave us the 250 units of tomatoes, which we know maximize profits. So now the question is, how much labor and how much capital does Ron need to have 250 tomatoes brought to the market? So remembering that the profit maximizing decision of how much to produce, which we already determined was $250, also elicits a capital and labor decision. So what are the profit maximizing levels of capital and labor? Well, the way that we do this is we plug the 250 in. We see that his profits are 125. Okay, just remembering that his profits are 125. And so all we need to do is then ask ourselves, okay, how many labor units and how many capital units does he need to have 250 tomatoes? Well, again, we already gave the functions for how many units of labor and how many units of capital he needed. We see that for 250 tomatoes, he needs 5 employees. And for 250 tomatoes, he needs at least half a unit of capital. Well, if we saw from this example, capital here is truck. So we're going to assume that any positive amount of a truck means he needs 1 truck. So we're just going to, round up and say that the profit maximizing amount of truck he needs is 1 truck. The important point is that this said 1.5, for example, that would mean he needs 2 trucks. If this was 2.5, he would need 3 trucks. So at 0.5, he needs 1 truck, and he needs exactly 5 employees to have this many number of tomatoes. So again, how did we find this, profit maximizing level of capital and labor? Well, we first, in that chapter 4 example, determined profit maximizing level of tomatoes, which was 250. And then we simply saw that the amount of labor he hires and the amount of capital that he uses is a function of tomatoes. And so if the profit maximizing level of tomatoes is 250, then that would imply that the profit maximizing amount of labor is simply the amount of labor he needs to have 250 tomatoes. And the same thing with capital. So I know that example seems very complicated, but hopefully I broke it down for you really nicely and concisely. And you're able to see again here how just a little bit of math allows us to dig deep here. And the point is that I want to show you that profit maximizing decisions aren't just about production, that there is an additional part of that story, which is that if a firm has a profit maximizing level of production, it also means that they have a profit maximizing level of labor and capital. And so profit maximizing decisions elicit profit maximizing labor and capital decisions. And of course, this has a lot of immensely important, consequences as it plays out in the labor market. One of which is that the hiring and firing of employees is typically made on a profit maximizing basis. And there are a lot of individuals, including a lot of economists, who believe that that is a certain amount of dehumanization, that we're sort of treating labor units just like we're treating capital units. And the truth is that in the context of businesses, there is absolutely some component of that going on. That labor units, and just sort of calling them labor units itself is a bit problematic. That thinking about labor as a profit maximizing component does take a human life and a human agreement of I'm going to give you some time of my life and you're going to pay me a wage. And it sort of takes that and sort of almost commodifies it in a particular way. But that point is a little inescapable in a market-based economic system. And so the question becomes, what do we do to ensure that there are worker protections, that there's some smoothing of that relationship between employer and employee? And again, this kind of goes back to that social contract conversation that we had in chapter 3. We sort of determine to what extent we want to smooth over the rougher edges of a market-based economic system. And in the context of labor markets, we've instituted all sorts of worker protections, from child labor laws to protections on job sites, rules regarding hours and the pay of overtime. All sorts of various laws and rules and regulations which have been created to smooth over that fact that in the context of profit maximization, there's a tendency to treat employees as units of a production function. And so we show that here in the math of economics, but I want to also elucidate kind of the general conversation about, okay, beyond the fact that this is just an interesting example of profit maximization to sort of drive home the point that profit maximizing production decisions cause capital and labor decisions as well. But I also wanted to kind of point out that we still want to make sure philosophically that we recognize that there's a real distinction between labor and capital. And they're two vastly different things in the context of the ethics and the morality that surround them. And so despite the fact that they're two components of the same profit function, two components of the same production function, the truth is that they are treated differently in the context of the economy, even in market-based economic systems such as the US, where we have a capitalist system, but we also have a slew of rules, laws, and regulations, which are meant to, again, treat labor specifically different from capital.